In this video, I'm going to be explaining adiabatic flame temperature and how to calculate it. So we're going to start off by saying that we have a system, and this system has an input, which is air and fuel. This system also has an output, which is going to be a flame, and this flame can be described as simply just hot gas. Now, the system here has a temperature going in, which we can just say is equivalent to 298 Kelvin. The system also has a temperature going out, which we're just going to call T, and that's what we're looking for. So, since our system is adiabatic, there is no heat loss. We're also using a steady state system, which means that the mass going in is equal to the mass going out. So when writing our mass energy balance, there's going to be no change in mass with respect to time, so that's just going to be equal to 0. And because there is no change in kinetic and potential energy, we can also write this side simply as our enthalpy and minus our enthalpy going out. And then obviously rewriting that, we can get our enthalpy going in is equal to our enthalpy going out. Now that we've defined this relationship, we need to incorporate temperature into it in order to solve for our final value T. So we can now write that our heat of formation at our final temperature T is going to be equal to our heat of formation at our initial temperature of 298 kelvins plus the integral from 298 kelvins to our final temperature T of our heat capacity with respect to time. Now, in order to solve for this heat capacity value with respect to time, we're going to have to use a certain equation that is called ChemCat equation 107, which I have listed here. Now, this first part, this A value, it's going to be relatively easy to integrate. It's just going to end up being A times T. But this section with our B and C and our D and E, that's going to be much more difficult. So I'm now going to transition us to Wolfram Alpha, where we're going to use that to calculate it. So now I have open Wolfram Alpha, and we're going to go ahead and type in that very first section. So we're going to say the integral, 4 parentheses here, of C over T divided by hyperbolic sine of C over T, and the whole thing is squared, and this is going to be with respect to T. Let's get the parentheses here. And so here's our first one. It's going to be the constant C times the hyperbolic cotangent of C over T. And if we can go ahead and put in our next one here, that's going to be E over T, hyperbolic cosine, E, and the whole thing is squared with respect to T. And this is, again, our constant E here. Wolfram Alpha just makes it lowercase for some reason. So here we have negative our constant E times the hyperbolic tangent of E over T. So let's go back to our board. Okay, so now that we've ran our equation through Wolfram Alpha, we can go ahead and rewrite this ChemCat equation 107 as becomes A times T plus B times C times hyperbolic cotangent of C over T, and that's going to be minus D times E times hyperbolic tangent of E over T. So now In our next video, we'll be coding this out.